Hello, Acute Angels! Welcome to another Mathinic episode. I am Teacher Nancy, your Mathematics 8 teacher. Are you excited to learn new something today? But before we start, kindly prepare your self-learning module or your book, your pen, and paper to write your solutions and answers as we progress with our discussion. Also, look for a place in your home where you feel comfortable and safe. And most importantly, prepare yourself to watch and listen carefully. This week, you will learn to solve problems involving systems of linear equations in two variables by graphing, substitution, and elimination. Solving systems of linear equations algebraically. But before we start, let us have first a short review. Find the equation for the indicated variable. For number 1, x plus 2y equals 8. Find the equation in the variable x. For number 2, 3x plus y equals 9. Find the equation in the variable x. For number 3, x minus y equals 5. Find the equation in the variable x. For number 4, 4x plus 3y equals 7. Find the equation in the variable y. And for number 5, x plus 4y equals 10. Find the equation in the variable y. I will give you 2 minutes to answer. Time starts now. Okay, let us check your answers. For number 1, the equation in the variable x is x equals negative 2y plus 8. For number 2, the equation in the variable x is x equals negative y over 3 plus 3. For number 3, the equation in the variable x is x equals y plus 5. For number 4, the equation in the variable y is y equals negative 4 over 3x plus 7 over 3. And lastly, for number 5, the equation in the variable y is
y equals negative 1 over 4x plus 5 over 2.
I hope you get all the answers correctly. Let's have another activity, the guessing game. Can you guess the number of chocolates and candies? Here are the clues. Clue number 1. The number of chocolates added to twice the number of candies is 33. Clue number 2. The number of chocolates is 6 less than the number of candies. How many chocolates and candies are there? Comment your answer below. Let us now start our lesson, solving linear systems algebraically. There are different methods to solve linear systems. These are by using the graphical method, which we already discussed on our previous episode. You may watch the graphical method on our week 8 episode. However, the graphical method of solving system of equations is not always convenient to use for the following reasons. The coordinates may involve large numbers or fractions that are difficult to plot. In this week's lesson, we will be discussing two other methods of solving systems of linear equations. These are solving linear systems by substitution method and by using the elimination method. First, the substitution method. Substitution method is solving for one of the variables in one of the equations and then substitute that variable in the other equation. It is anchored on the substitution principle, which states that if two expressions are equal, then either may replace the other without changing the equality. We follow these steps when solving a system of equations in x and y using the substitution method. Number 1. Solve one of the equations for either x or y. If one of the variables in an equation has a coefficient of 1 or negative 1, choose that equation since the substitution is easier this way. Number 2. Substitute the expression obtained in step 1 into the other equation. The result is an equation with one variable. Step 3. Solve the resulting equation in one variable from step 2. If the result is a false statement, then we have a system with no solution. However, if the result is a true statement, we either have a system with infinitely many solutions or one with exactly one solution. In step 4, substitute the result in step 3. Substitute the result in step 3 into any equation containing both variables to find the value of the other variable. And lastly, check the solutions in each of the original equations, then write the solution set. For example, solve the system of linear equation x plus y equals 9 and 3x plus 2y equals 22 using the substitution method. X plus y equals 9 is our equation 1 and 3x plus 2y equals 22 is our equation number 2. Solve for x in equation 1. So for our equation 1, we have x plus y equals 9, and then using the addition property of equality, we will add negative y on both sides to get x equals 9 minus y. That will be our equation number 3. Next, substitute the expression obtained in step 1, which is 9 minus y for x, in equation 2 to get an equation in terms of y. We have 3x plus 2y equals 22, which is our equation 2. We now substitute 9 minus y in place of x to get 3 quantity 9 minus y quantity plus 2y equals 22. Then distribute 3 to 9 minus y. We have 27 minus 3y plus 2y equals 22. Then solve for y. 27 minus y equals 22. Negative y equals 22 minus 27. Simplifying the equation gives us y equals 5. Next, substitute the value of y in equation 3, which is x equals 9 minus y. Then solve for x. x equals 9 minus y. Substitute 5 in place of y. We have x equals 9 minus 5. So the value of x is equal to 4. Then check the solution. X equals 4 and y equals 5 in both equations. In equation 1, we have x plus y equals 9. Substitute 4 for x and 5 for y. We have 4 plus 5 equals 9 and 9 is equal to 9. Our solution is true in equation 1. Let us try substituting the solution in equation 2. Again, substitute 4 for x and 5 for y. Our equation 2 is 3x plus 2y equals 22. We have 3 times 4 plus 2 times 5 equals 22. 3 times 4 is 12 and 2 times 5 is 10 equals 22. 12 plus 10 is 22 and 22 is equal to 22. Our solution is also true in equation 2. Therefore, the solution for the system x plus y equals 9 and 3x plus 2y equals 22 is 4, 5. Let us have another example. Solve x minus 3y equals 3 and 2x minus 6y equals 5 using the substitution method. X minus 3y equals 3 is our equation 1 and 2x minus 6y equals 5 is our equation 2. Now solve for x in equation 1. We have x equals 3 plus 3y and that will be our equation 3. Next, substitute the expression 3 plus 3y for x in equation 2 to get an equation in terms of y. Our equation 2 is 2x minus 6y equals 5. In here, we will substitute 3 plus 3y in place of x in equation 2. We have 2 multiplied to the sum of 3 plus 3y minus 6y equals 5. The result is 6 plus 6y minus 6y equals 5. 6y minus 6y is 0. The result is 6 is not equal to 5. Since no variable was left and 6 equals 5 is not correct for any value chosen for x and y, there is no solution to this system of equations. The system of equations is inconsistent. If we are to graph the equations of this system, the lines would be parallel. Here's the graph of the system. As you can see, the two lines are parallel. Let's have another example. Solve the system 2x equals 5 quantity y minus 2 quantity and 1 over 5x minus 1 half y equals negative 1 using the substitution method. Our equation 1 will be 2x equals 5 quantity y minus 2 and our equation 2 will be 1 over 5x minus 1 over 2y equals negative 1. First, simplify each equation before solving them simultaneously. Apply the distributive property in equation 1. We have 2x equals 5y minus 10. Then we will rewrite it in standard form. We have 2x minus 5y equals negative 10. And that will be our equation 3. We can now solve for x by dividing both sides by 2. We have x equals 5y minus 10 all over 2. And that will be our equation 4. Next, multiply the equation 2 by 10 in each side. Multiplying the equation 2 by 10 in each side gives us 2x minus 5y equals negative 10. This will be our equation 5. Then, x equals 5y minus 10 all over 2 in equation 3. We have 2 quantity 5y minus 10 all over 2 quantity minus 5y equals negative 10. The result is 5y minus 10 minus 5y equals negative 10. Simplifying this gives us negative 10 equals negative 10. Since no variable was left and the resulting equation is true, the result indicates that the equations of this system is dependent. Hence, the system has infinite solutions. Graphing both equations will result to the same line. Let us now move to our next lesson, solving linear systems by using the elimination method. Here are the steps in solving systems of linear equations in two variables by elimination. First, write both equations in the standard form ax plus by equals c. Second, look for the terms of the equations that are opposites. Step 3. If there is none, multiply one or both equations by appropriate numbers so that the sum of either x or y is 0. Step 4. Add the new equations to eliminate a variable. The sum should be an equation with only one variable. Step 5. Solve the equivalent system by adding the two equations. Step 6. Substitute the result in Step 4 into either of the given equations and solve for the other variable. And Step 7. Check the solutions in each of the original equations. Then, write the solution set. For example 1, solve the system 3x minus 5y equals 13 and 4x plus 5y equals negative 6 by elimination method. 3x minus 5y equals 13 is our equation 1, and 4x plus 5y equals negative 6 is our equation 2. In this example, equations 1 and 2 contain the terms negative 5y and 5y respectively. Eliminate y by adding equations 1 and 2 to form a new equation. So we have to add 3x minus 5y equals 13 and 4x plus 5y equals negative 6. Adding these two equations eliminates negative 5y and positive 5y. The result is 7x equals 7. Simplify this by dividing both sides of the equation by 7, so the value of x is equal to 1. Now, substitute x equals 1 into equation 1 and solve for y. Our equation 1 is 3x minus 5y equals 13. Substitute 1 in place of x. We have 3 times 1 minus 5y equals 13. Simplify this, gives us negative 5y equals 13 minus 3. Negative 5y is equal to 10. Then divide both sides by negative 5. The result is y is equal to negative 2. Thus, the solution for this system is 1, negative 2. To check the solution, substitute the value of x and y, which is 1, negative 2, in the original equations. For our first equation, we have 3x minus 5y equals 13. In our first equation, substituting 1, negative 2 gives us the final statement 13 equals 13. Therefore, 1, negative 2 is true on our first equation. We also have to substitute the solution set 1, negative 2 on our second equation. On our second equation, substituting 1, negative 2 gives us negative 6 equals negative 6. Therefore, the solution set 1, negative 2 is also true in equation 2, and the solution set is true for the system 3x minus 5y equals 13 and 4x plus 5y equals negative 6. For our example number 2, solve 2x plus 3y equals 7 and x minus 2y equals negative 7 by elimination method. 2x plus 3y equals 7 is our equation 1, and x minus 2y equals negative 7 is our equation 2. To eliminate x, multiply equation 2 by -2. Multiplying the equation by -2 gives us -2x plus 4y equals 14. This will be our equation 3. Next, add equations 1 and 3. Equation 1 is 2x plus 3y equals 7 plus the equation 3, -2x plus 4y equals 14. 2x and -2x are eliminated, so the result is 7y equals 21. Now divide both sides by 7 to get the value of y equals 3. Next, substitute y equals 3 in either of the given equations. If we choose equation 1, we have 2x plus 3y equals 7. Substitute y equals 3. We have 2x plus 3 times 3 equals 7. 2x plus 9 equals 7. 2x equals 7 minus 9. 2x equals -2. Divide both sides by 2. We have x equals -1. Thus, the solution is -1, 3. Check the solution by substituting -1, 3 in the original equations. The result is true for both equations, therefore, the solution set -1, 3 is correct for the system 2x plus 3y equals 7 and x minus 2y equals -7. For next example, solve x minus 4 over 5y equals 2 and 5 over 4x equals y minus 3 by elimination method. X minus 4 over 5y equals 2 is our equation 1 and 5 over 4x equals y minus 3 is our equation 2. For this, clear both equations of fractions. In equation 1, multiply 5. We have 5x minus 4y equals 10. That will be our equation 3. For equation 2, multiply 4. To eliminate the denominator 4, we have 5x equals 4y minus 12. Now write equation 4 in standard form. 5x equals 4y minus 12. Rewriting this in standard form, the result is 5x minus 4y equals -12. This will be our equation 5. Next, subtract equation 5 from equation 3. 5x minus 4y equals 10 minus 5x minus 4y equals -12. 5x minus 4y minus 5x minus 4y is 0, and 10 minus -12 is positive 22. 0 is not equal to 22. Since no variable was left and 0 is not equal to 22, the two variables in this example were eliminated. Our last example shows that using the elimination method may result in the elimination of both variables. We now have the following generalizations. The number of solutions in the elimination method, if the resulting equation is false or a contradiction, the system is inconsistent and has no solution. And if the resulting equation is true or an identity, the equations are dependent and the system has infinitely many solutions. Hello, Acute Angels. Think about this. Do we really need to package something that takes 5 minutes to eat in a material that takes hundreds of years to break down? The world is having to confront the toxic results of our love affair with plastic.
Could we humans offer some substitutes?
That ends our Week 9 lesson for Quarter 1. That's all for now. You did great watching and listening. I hope you have learned something from our lesson today. See you in our next episode. Keep safe and God bless us all.